Hello, in this video I'm going to show you how to use the AHRS attitude sensor in your ADL device. So this applies to all the ADL devices which have the AHRS sensor, which means the ADL180 or 180B version I have here, or the ADL190 or 200 devices. So to configure and run the AHRS, obviously first step is we have to turn on our ADL device. So we push the button on this one, green light is on. Here on the screen you can see what my iPad is doing. And we are in the Wi-Fi configuration of the iOS and wait for the ADL Connect Wi-Fi to show up. Here it is, we select it, we make sure we really get a blue check mark on the name of the Wi-Fi. The orange warning, no internet access, below the name of the Wi-Fi is no issue, that's normal, because the Wi-Fi is only between your iPad or iPhone or Android device and the ADL device. There's no outside connection, but that's not a functional problem, that's normal. So we switch over to the ADL Connect app. For the purpose of this video, I'm using the latest app, which is currently, you can see it here, and you have app version is 9.10, and below you see the firmware version running on the device, which is also 9.10, and this is the latest version with quite some upgrades, especially regarding the AHRS. So if you are trying this feature, update your app and your ADL firmware first before even going any further. So the actual display of the AHRS data is on the moving map page, and we select the little AI button in the left top corner. And then we get this kind of artificial horizon. We are mostly interested in now in the AHRS part, so basically the horizon, but you also get the ground speed and altitude, but that comes from your GPS and the ADS-B sensor, which is another topic. So we are just interested basically in the pitch and bank. So in this example we are quite lucky, the device is already very stable and flat, but that doesn't have to be always the case. There's quite some configuration possible. So the first thing to notice is that when the device is very stable, you will see this sync gyros message, which means that the device detected it's sitting very stable, and so it can adjust its internal gyros. This will usually not be the case in flight. As soon as the device detects any vibration, usually the engine of the aircraft or any sort of movement of the aircraft, it will no longer synchronize the gyros. You can see here, even if I start rocking on the table, the sync gyro goes away. So it's very sensitive to that. But it can run for many hours without the sync gyros. It's just every few months or so, probably if the temperature changes, if the device, the hardware ages a little bit, it needs to readjust. And so the best way to do this on a mobile device is to have it basically sitting on your table somewhere or in the aircraft without the aircraft engine running. As soon as the engine is running, it can usually no longer synchronize those gyros. So then, yeah, so once you have the gyros synchronized, you can make sure you have basically your zero pitch attitude and zero bank attitude adjusted. So I'm going to place it here a little so you can have a better look. And in this example it's flat with the table, but we can have an example. For example, let's say in your aircraft the position is a little bit more like this, because your glare shield is going down, for example, and then if you just place the device, it's going to look like this. But now obviously you want it to be flat and zero pitch, and then you have this setup button you can press, and then you have different options. One is reset. We can do that. That basically resets the whole sensor to its factory default position. So we see there's a pitch down situation now, but it's not perfectly flattened because there's slight tolerances in how the sensor is installed, how the device is installed, and so on. And so the next step is you can press the set level button, and that's telling the device that the current position it's in is the level position for your aircraft. So you have no pitch, you have no bank. Usually the best way to do this is to fly with the autopilot in level flight. You can also try this on the ground, but most aircraft will not have the correct pitch attitude on the ground because your gear will be your gear struts have slightly different extensions, and you might have a little fault in there. So in my experience, the best way is if you have an IFR flight, you're really in smooth air in the flight levels usually, and then and try the set level and to teach the device basically your level position. But you can also do it on the ground, and then you have to accept a few degrees maybe of error. And in most cases that should already be enough. So now we can say done, and we teach the device our orientation. So now if we pitch up, it goes up. If we go back to the old status, it's zero pitch, we pitch down. And now we do a roll movement. It rolls in the right direction. This is because currently I assume that the direction of flight is basically this axis of the device. This applies to all the ADL devices. So basically on the ADL190 and 200 you have the connectors in the back, and if you do not teach them something else, they still assume that your direction of flight is this longitudinal axis of the housing. This means that the device thinks this movement is pitch and this movement is bank, which in this case is right. But especially for the ADL 190 and 200, they can be installed in all kind of positions. There's no limitation what position you can use. So for example, to have to give an example, in my aircraft, if this is the direction of flight, the ADL200 device is actually installed in this direction. So as you see, it's not working properly. We can do the first step. We do the set level. The set level. We have a level, but now obviously if my aircraft would pitch up, it's this movement. But you see the ADL device is thinking it's banking. And if we roll our aircraft, the ADL device thinks it's pitching. So obviously, yes, this is not enough. So if you have any configuration where your ADL device is installed not in the longitudinal axis with the housing aligned with the aircraft, you have to teach it some more. And therefore you can again open the setup menu, and then you see there's a second step: pitch up, no bank, or pitch down, no bank. You only have to do one of those. And the idea is that when you are for example, in a pitch up, in a stable pitch up position, then the device can learn what is pitch. So for example, if we climb in our aircraft, obviously the device will be in this position. Again, it's important to have no turbulence. So this is again best done on the autopilot in the flight level. If you are in a constant climb, the more pitch you have, the better, but obviously do not stall your aircraft. But if you have more pitch, it's easier for the device to detect. And so we are now in our climb. And then I press the pitch up, no bank button. Done. And we see our bank did transform in a pitch up movement. And now if we use the device, we see this is the pitch axis, and a movement here is the roll axis. And so now the device is properly calibrated for an installation situation where it's basically not aligned with the aircraft axis. And this will work in any orientation. So you can even have it like that in your aircraft. You just have to follow those two steps to teach it its position. You can always undo this. You can always go to the setup. You can go reset, and then it's back to its factory default. Obviously, you see it's thinking it's 90 degrees rolled in this situation. Then you can set the level, and then you can reset the second step. Basically, it's so that when you reset a different level position, your second configuration step is always basically undone. So you have to redo that. You can, but you can redo the second step as often as you want, and you will not lose your first step. So basically, whenever you use the first step, second step is gone. When you just reuse the second step, you can do it as often as you like until you are satisfied. In the aircraft, you sometimes have to do it one or two, maybe 2 times, depending. If you have a little vibration and at the wrong moment, it might not get the proper configuration, and so this needs a little bit attention to detail to get it right. Thereafter, this data is stored in the device, so you do not have to redo this on any future flight. So if you do not make any changes to the aircraft, basically to configuration or installation, it should stay the same all the time. Maybe one word on the gyro sync I talked before. So for the portable device, it's actually quite easy. You put it on the table. If you have an installed device which is permanently installed in the aircraft and hooked up to the avionics bus, which is quite typical, in normal cases you will obviously only start up the avionics bus when the engine is running. So the device might never get the chance to properly calibrate its gyros because it's never running without the engine running. So to make, if you feel that the gyro is wandering in some direction, it's not stable and so on, it's a good idea basically to turn on the avionics bus for a few minutes, maybe 3-4 minutes, without the engine running, and have the ADA device give the ADA device a chance to properly calibrate without having all the vibration from the engine. That will greatly enhance the quality of the gyro calibration it's running on. And just in case you ask what the second green thing is, it's gravity stabilization. That's on all the time. The device can stabilize on gravity, obviously, because the Earth is turning. You have Earth turning 15 degrees per hour, and the gyro wants to be stable in space. On top of that, we have the Earth moving around the Sun and many more things. So any gyro will drift over time and not stay vertical with gravity, which you wanted to do. And so every such gyro system has to stabilize with gravity over long periods of time. And the issue is, a classic is if you fly circles for a very long time, like for half an hour, a gyro might align with your perceived gravity in the turn and not the real gravity of the Earth. So this adjustment is done very slow, and the ADL device tries to detect basically through the GPS data when you are going straight and level, not accelerating or not decelerating very much, and then it can stabilize its to the gravity and make sure that this 15-degree drift per hour and so on does not shift out of place your attitude sensor over time. You can try this on the desk. Basically, a very hard test for the ADL devices is if you take it and if you turn it around like this. This is obviously, if it would be in flight, would be just crazy. And then you can replace it. This was, you see, it accumulated a little error of approximately 5 degrees through this more than radical maneuver. And now you see the gravity stabilization doing its thing and pulling it back to the perfect position to correct this error so it does not add up over time. Obviously, this kind of maneuver would be extreme even for an aerobatic plane. I think it cannot turn that fast, but it's a good way to challenge the AHRS sensor in testing. Yes, thanks a lot for watching, and if you have any more questions or suggestions, just contact me. Best is to use the email address on the website. Goodbye.